like it'll say blah, 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 blah. You're gonna put L1 in that first blah, blah, and you're gonna put L2 in the second blah,
Next to
blah.
frequency, okay.
Yes. And that should also remind you that frequency is gonna be your L2. If you put the comma only goes if it looks like that. If it doesn't give you those lines, the options, it's gonna be one var stats L1, comma, L2.
Okay.
But if it gives you those blah, 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 it's L1 in the first one, L2 in the second one, and I think the third one says calculate.
Yeah.
And what are we looking for again?
We are looking for the mean and the sample standard deviation.
Oh, okay.
What is my mean?
23,220.97.
Yep. I'll put over here, 23,221.97. And what is our sample standard deviation?
It'd be 220.97.
Yeah, it's you
Instead
rounded
of
up.
221.
I went ahead and rounded it while I was writing it. What's your sample standard deviation?
22,484.
4.51. And that was 22,484.51312, blah, 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 blah. Not that bad, was it? You just gotta remember, am I doing L1 only? Am I doing L2 only? Am I doing L1 and L2? Now, the next one is the same thing. I'll just let you watch this one. First thing we have to do is we have to find our midpoints. For example, if I want to know this midpoint,
3,000 minus 2,000. Or 3,000 plus 2,000 divided by 2.
this one,
3,000 plus 4,000.
Oh, yeah. that's
add
what I
these
meant.
up, divide by 2, and back that thing up. So you're always going to use the one ahead of it and then back that thing up. So 3,000 plus 4,000 cut in half,
Yeah.
3,500.
3,500. So you'll get your midpoints. That will be your L1, and your frequency will be your L2. So I've worked, y'all don't have to work it out, but I just, let me put over here, and I'm just going to randomly pick those two that I picked just now. I did those two. So I did 3,000 plus 4,000 cut in half. That's where that 3,500 came from. This is going to be my L1. This is going to be my L2. I type them in. They want the mean and the standard deviation. And this time they were doing population. So we looked at the X bar, but we called it the mu because it was the population. And then we looked at the sigma X, but we did everything exactly the same. Yay? Now, it says according to the empirical rule, which is the 68, 95, 97, 68% of all babies will fall between which two weights? Okay, in order to do the empirical rule, what goes in the middle?
Mean.
The mean. What do you jump off the mean?
Standard deviation.
The standard deviation. So they gave me what I needed right there. So for this picture, my mean is what goes in the middle, the 3281.5. My standard deviation is what I'm jumping. So I will add 648.8 and I will subtract 648.8. And because it's 68%, I'm only going to do one jump. So once I subtract 3281.5 minus 648.8 and add, that's going to give me my two answers. Yay? So you knew everything you were supposed to know, but if you screwed up the mean and standard deviation, then you're going to screw up this, which is why I say don't wait till the last minute to do the homework, because there's 47 parts to some of these. So 68% of the babies weigh between blah and blah.
Oh, yeah, so you just would have had to add the deviation and subtract the deviation.
Off of the mean.
Okay.
So the mean was 328.5, and this was your standard deviation. So I would do this plus this to give me that, and this minus this to give me that.
Yeah.
So 68% of the babies fall between this and this.
That makes sense.
Had it said 95%, I would have done this plus this,
Uh-huh.
and this, minus this, because
Yeah.
95 would have been the two jumps.
Yeah.
What was the question for that one again?
It said what two values,
Okay, so it wanted the actual,
the actual data
Okay.
points, the actual values. Yep. Yep. Class average. Now, a lot of us used to do this old school. We would say take the grade, multiply it by percentage, plus take the grade, multiply it by percentage, and take the grade and multiply it by percentage. We could still do it old school, but the calculator's gonna make it a lot easier. We have, let's see what I'm on. We have the grade, what am I doing, class average? We have the grade, and we have the weight. So, what's the first one? Calculus counts 5%. Calculus is 5%, and what do we make in calculus? Oh, attendance. Attendance is 5%. What do we make in attendance? 100. And then quizzes are 10%, and we made a 93 for quizzes. And then exams are 60%, and we made an 86 on our exams. And then final is 25%, and we made an 85 on our final. So our last column is our frequency or the weight. How much does it weigh? What is the frequency? And then this is going to be our data. So I made 100 on attendance, and it counted 5%. I made a 93 on quizzes, and it counted 10%. I made an 86 on exams, it counted 60%. I made an 85 on my final exam, and it counted 25%. This is going to be my L1. This is going to be my L2. So if I come over here to my calculator, and I'm going to do stat edit, go to the top, clear enter, come over, go to the top, clear enter. Now, if for some reason your columns are not the same length, it's going to yell at you because you're comparing or you're using both of these. So it's like, oh, everybody's supposed to have a partner, and if everybody doesn't have a partner, it's going to yell at you. So let me just show you. If I put another number down there, and I try to do something with it, if I try to do stat calc 1var stats, and I do L1 and L2 to let them know that I'm trying to do both of them together, it's going to yell at me and say, there's a mismatch. That means they're not the same. Everybody doesn't have a partner. So that's when I go back and say, go to what you don't like. And it's saying I don't like that there's not an L2 in there. So I'm going to go in and I'm going to delete the one that doesn't have a partner. So there's my L1, L2. And then I'm going to stat calc 1var stats, and I'm going to do L1 and L2 because I have two sets of data and those data are related to each other. And then I'm going to calculate it. I want to know this person's GPA. Which piece of data do you think I'm going to look for GPA? The X-bar, the mean. So there is her mean. So that does save a little bit of time just typing it in there and making sure that you use L1 and L2. Your weight or your frequency is always going to be your L2. All right, there's a couple more examples. We're not going to make you do every single one of them, but just to show you. This one's pretty cool. You go to the candy store, you decide to buy, can't decide between peanuts, cashews, or almonds, and they agree to mix it for you. Well, they got to know what to charge you. because they're mixing all this together. You buy 2.5 pounds of peanuts for $1.30 per pound, 4 pounds of cashews for $4.50 per pound, 2 pounds of almonds for $3.75 per pound. Determine the price per pound. We have 2 sets of data. I need to know which number is going to go in L1 and which number is going to go in L2 and why. I have money and I have pounds.
Pounds of frequency.
Pounds is your frequency, pounds is your weight. Your second number, your L2, is always going to be your weight or your frequency. So when I come over, I bought $1.30 for 2.5, $1.30 for 2.5 pounds. I bought $4.50 for 4 pounds. And then I bought 2 pounds for $3.75. There's my data. I type that in L1 and L2. And y'all, it even says it right here. Price per pound. Price is first, pound is second. That also reminds you of your L1 and your L2. When I go to do 1 bar stats, I have to make sure that I'm doing 1 bar stats of L1, L2. 1 bar stats of L1 and L2. And I want to know the price per pound. So what do you think I'm going to be looking for? The mean, the X bar. And because it's money, we're only going 2 places behind the decimal. 2 places behind the decimal. Because money only goes 2 places behind the decimal. So we would be charged $3.38 per pound for the mixture. GPA. We can also do this with GPA. Your first is going to be, your L1 is going to be your X values, your L2 is going to be your weights or your frequencies. We just talked about that. Let me come over here, because I got it everywhere. Hold on. Marissa just finished her 2nd semester and she wants to know her GPA. She made a B in a 5-hour calculus course, an A in a 3-hour social work course, an A in a 4-hour biology course, a C in a 3-hour American literature course. So, up until here tells us what her coursework is. Now, most of us should know, if you make an A, what does that mean mathematically? What number goes with an A?
90 or above.
GPA-wise?
4.
4.0. And a B is 3.0, and a C is 2.0, and a D is 1.0, and an F is a 0. So that's what this last sentence is telling you. Assuming that an A is a 4 points, a B is a 3 point, a C is a 2 point. If they made a D, it would be a 1 point, and if they made an F, it would be a 0. So I've got to have an L1 and an L2. I have a grade, and I have an hour. Which one's going to be my L1 and which one's going to be my L2? Your hour is your weight. It weights as a 4-hour course. It weights as a 3-hour. Here, y'all, almost everything is a 3-hour course. But if you go to a 4-year school, you have, I went to college and we had to take tennis, an hour class of tennis. And when I was in my sorority friends are like, oh, y'all, I made a C in biology, and I made an A in tennis. That's going to average out to a to a B. And I'm like, biology is a 4 credit hour course. Tennis is a 1 credit hour course. This counts 4 times as much as this one. They're weighted differently. Now, had it been an A in a 3 credit hour course and a C in a 3 credit hour course, then it would average out to a B because they're weighted the same. So you've got to take into account the different weights. So the first thing you do is we come over here, and I'm going to move this and we'll just write this together. So in her first class, and we don't care what the class is, she earned a B in a 5-credit-hour course. Then she earned an A in a 3-credit-hour course. Then she earned an A in a 4-credit-hour course. Then she earned a C in a 3-credit-hour course. Well, we can't deal with math with letters, so we have to turn those letters into numbers. So that A is going to become a 4.0. The other A is going to become a 4.0. This is going to become a 3.0. 2.0, if it was a D, it will become a 1.0. If it was an F, it will become a 0. This you're going to put in your L1. This you're going to put in your L2. You're going to do 1 var stats. And you're going to do the 1 var stats of what? L1 and L2. So you're going to do the 1 var stats of L1 and L2. And what do you think we're going to look at to get their GPA? The X bar. And usually their GPA is going to be 2 places behind the decimal. So this person has a little bit over like a B plus, a little, it's not a B minus, just a normal B, 3.27. So they made 2 A's, a B, and a C, but their A's were weighted heavy. Their C was not weighted as heavy. So that pulled it up just a little bit. Cool? Questions? That is it for that section. Can we breathe? Now we're going to start 3, 4, and 3, 5. Let me open those notes. And we're not going to get all the way through 3, 4, and 3, 5. But we'll get a good start to it. And let me pull up while I'm pulling that up. As far as what's going to be on the test, we've done Pareto charts. Now, in this class, does Pareto charts go from least to greatest or greatest to least? Greatest to least. Pareto charts go in descending order. Class width, class limits, we talked about those last times, the difference between a bar graph and a histogram, we talked about they touching. The shape of the distribution means is it left skewed, right skewed, or symmetric. Determining the mean, that's going to be your X bar. The mode is going to be the number that appears the most. The shape is going to be just like that one. The variance is going to be your standard deviation squared. Calculate the standard deviation, and I may be asking for population or I may be asking for sample. I didn't tell you. Use the empirical rule. You have 2 questions on that, the 68, 95, 99.7. You can either memorize those little baby numbers or not. It's totally up to you. Approximate the mean for group data. That's the one where we added them up and found the midpoint. Added them up and found the midpoint. That's your L1, that's your L2, and you're going to do 1 var stats of L1, L2. Calculate the weighted average. That would be like a GPA problem that we just did. The last 3 problems we did were weighted average. Now we're into 3, 4. Okay, you're going to have 1, 2, 3, 4, 5, 6 questions on 3, 4. Okay? All right. Let me pull up an example to show you what a z-score means. Mean standard deviation. Let's say the mean was 100 and your standard deviation was a 20 and it was a normal distribution. We should all know how to draw that by now. Normal distribution with a mean of 100, a standard deviation of 20. I'm going to go ahead and do 3 to the right and 3 to the left. So I'm going to do 120, 140, and 160. I added 20, 20, and 20. And then I'm going to subtract 20, subtract 20, and subtract 20. That's what we've been doing all along. Cool? Now, up until now, we've been doing pretty jumps. This was a jump, this was a jump, this was a jump. This was a jump, this was a jump, this was a jump. These are all called pretty jumps. But what if my data was not 140? What if my data was 130? Do you agree that's not a pretty jump? So what if I didn't want to use the data number 140? What if I wanted to use 130? Okay?
It's like half step.
So, do you agree that 140 is 2 jumps
Yes.
away from the mean?
Yeah.
We call that 2 jumps to the right, or positive 2, because you're going above the mean. This would be how many jumps?
3 to the left.
Which would be a
-3.
-3. So your z-score, which we're getting ready to talk about, your z-score is the number of jumps you are from the mean. You are meaning the data is from the mean. So example, this would have a z-score of 3 because it's 3 jumps above the mean. This would have a z-score of
-2.
-2 because it's 2 jumps below the mean. Okay?
Yeah.
What does this have a z-score of?
0.
If the class average was 100 and you made 100, how far were you away from the average?
0.
Nothing. So that has a z-score of 0 because you are 0 jumps from the mean. So these are all pretty jumps. Now this one's not a pretty jump. And sometimes they're even going to be even uglier. So most of you can kind of tell me how many jumps is that going to be. How many jumps is that going to be?
2.5.
1.5 jumps. Y'all with me? Well, there is a formula for z-score. How to find the z-score? The formula for the z-score is data minus mean over standard deviation. Data minus mean over standard deviation. Now, we don't have to do it if it's pretty. I mean, we could, but we don't have to. I mean, I can do this one just to show you. If I wanted to know the z-score of that one using the formula, it would be data minus mean over standard deviation. My data is my data point, which in that case is going to be 160. What is my mean? 100. And what is my standard deviation? 20, which would be 60 over 20, which would give you a z-score of 3, telling you that it's 3 jumps away. So for this one, 130. If I do data minus mean over standard deviation, what is my data point? 130. That's where I'm standing at the moment. What is my mean? 100. And what is my standard deviation?
20.
So that is 30 over 20, which is 1.5. So that tells me I'm 1.5 jumps away. Which y'all could see that I took a whole jump and then I'm halfway between those two, so it's 1.5 jumps. It's positive because it's that way. If I jump this way, it's going to be negative. So this kind of tells you about, so we have percentages. Percentages are what's underneath the curve. Percentages are when I shade. Right, data points are when I add and subtract from the mean. Those are the data points. What we're talking about now is how many jumps. To the left, to the left, to the right, to the right. Now slide. That's what we're talking about right now. Jumps. That's the z-score. So on this page, it says, this is 3.4 and 3.5 notes combined. It says z-scores provide a way to compare apples and oranges with different spreads with the same center. And again, it's a fancy way. We're going to talk about that z-scores are going to be the number of jumps. And we can compare different data like car 1 and car 2, we can compare that by comparing the size of their jumps. And we're going to do that in just a second. And this is what I just said. They call it X, I call it data. I do data minus mean over standard deviation. All right, so they gave us some information. And I'm going to draw a picture. Let me slide this down just so that I can show you. All right, if I draw you a graph, they gave me, all of this was given. And the question is, who has the relatively highest class average? So, Bobby makes a 72 in biology. The class average is a 65, the standard deviation is 10. Jim makes a 91 in bowling. The class average is an 88, the standard deviation is 6. 82 was made by Sally. Class average was a 74, the standard deviation is 12. I want to know who made the best class average relative to the class. Okay? All of the class averages are in different spots. And everybody's spread is different. So it's like you're on a boat. Everybody's going in a different spot. So I need to be able to compare them. And I'm going to compare them by the size of their jump. Are you a little jump away from your teacher? Or are you a big jump away from your teacher? So if I were to draw biology, going from 0 to 100, their average is what goes in the middle. So let's start. There's 0 to 100. Okay, her average, let me put 50, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 10, 20, 30, 40, 50, 60, 65 is going to be the mean. And so that's going to be like my hump right there. You with me? So there's my mean of 65. My data point is 72, and my standard deviation is 10. Cool? So if this is 65 and my jump is 10, where's my first line going to be?
Right behind you.
75.
At 75. So do you agree that this person is not a whole jump?
Yes.
Okay? This next line is going to be right here at 75. So this person is a little less than a jump away from the class average. We good? Let's look at bowling. I'm trying to line it up almost underneath it so that you can kind of get an idea. Okay, what's the average of this class? 88. So that's where the hump is going to be. So 88 is here. So that's where my hump is going to be. And my data point is 91. And my standard deviation is 6. So this was an 88. This was a 6. So where's my next line going to be?
94.
94. And this data point was at 91, and this data point was at 72. So do you agree they're both not a whole jump?
Yeah.
But they're kind of not on top of each other, so I can't really compare them because they're not on the same graph. So now if I go to statistics, okay, their average is a 74. 10, 20, 30, 40, 50, 60. 74 is going to be about right there. So that's where their hump is, because the mean, median, and mode fall in the hump when it's symmetric. 82 is their data point. And they have a standard deviation of 12. So where's their next green line going to be? 74,
86.
74,
86.
86, my bad, I can't write. 86, that was a 74. 86. So they're all within one jump. So they're all doing pretty good. So we need to know exactly how many jumps away there are. So we're going to do the z-score. Data minus mean over standard deviation. Data minus mean over standard deviation. Data minus mean over standard deviation. So for the first one, what is my